Hello students, this is for class 11th. We are going to study a very important mathematical concept called vectors. First and foremost, let us say a word scalar, and then we come to the concept called vector. What is a scalar? In physics, whatever you can measure, the measurable quantity is called a physical quantity. Length, mass, time, all these are measurable quantities, right? So, I say length, mass and time. I have taken basic quantities. Now, when you talk about scalar, the scalar has only magnitude. Magnitude means number, the value. Let us say, I say 5 kilograms of sugar. You see, here I have got a number and there is a unit, kilogram. So, this is a physical quantity and this is a scalar quantity. Or for example, I say the temperature of a particular person body is 37 degrees Celsius. Now, this 37 is the number, the magnitude, and degree Celsius is the unit. Many of the physical quantities has unit, right? Some of them may not have also, that doesn't matter. But whenever you express a number, then that is called a scalar quantity. For example, when I take distance, right? Now, I am going to talk about distance as a physical quantity, right, which we learned in the previous lesson. Let us say 5 kilometer distance. I walk every day 5 kilometer. That is distance. Okay, I may walk 5 kilometer in Delhi or in Mumbai or in Chennai. Anywhere I can walk, or I can walk in a village. Now, that 5 kilometer distance is a scalar quantity, and 5 is the number, which is magnitude, and kilometer is the unit. Now watch carefully. Now when I say 5 kilometer distance, I am going to go from point A to point B, which measures 5 kilometer. Suppose I come to the next point, vector. Then what is a vector? When I talk about displacement, right? Displacement is a vector quantity. Now, how does it become a vector quantity? Why displacement should be a vector quantity? Let us see. 5 kilometer. Again, the person is traveling 5 kilometer. He is moving some point from A to B. We don't know. But when you say it's a vector quantity, the displacement is a vector quantity, then you need two things. One is magnitude, plus what you need is direction. Direction is also very important. In which direction are you walking? Yeah, that is very important. Now we know basically there are 4 directions we are talking about. Okay, now let me take the directions here: north, south, east and west. And this is, we can say, a reference point. Now, when I represent displacement and when I say that it is a vector quantity, yes, 5 kilometer. 5 kilometer towards north direction. That means I have to take from here 5 kilometer in the north direction. In west direction, there the direction is also brought into the system. Okay, now with that idea that a scalar is only has magnitude and a vector has both magnitude and direction, why should we have a mathematical quantity concept in physics? Because in the previous chapter we studied about motion in a straight line. So when you talk about motion in a straight line, okay, let us say this is a straight line. I am going to draw a straight line. Okay, when somebody is walking in a straight line, Here you have only one direction and you can say that direction is x direction. Fine. Yes, person is starting from here. This is the origin point. He travels 5 kilometers, let us say, right? And I measure very carefully. I take this equal to, right? I'll mark 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, and then I will say 5 kilometer. So this every point I make a very precise measurement, right? And this line represents 5 kilometer. This line represents, but this is only one direction. Okay, even if the path is curved, no problem. Okay, it is also, we approximate to be a straight line. Why? Because whenever I want to locate the body will be only in this road, right? Let us say I start from, let us say a point from Delhi, New Delhi railway station. I start from New Delhi railway station and I go to Connaught Place, right? CP. Then what will happen? I go only in that particular path. So you can locate me when I am traveling in that particular road. So this can happen anywhere. Fine. So here I don't need direction that much. You only know one thing. You start from New Delhi railway station and you reach Connaught Place. There ends the matter. But when I say about displacement, I have to specify the direction. Okay, so how do you represent a vector quantity? We represent a vector quantity by a straight line like this. Okay, so this represents a vector quantity. Let us say this is point P and this is Q, then PQ is a vector. You see, above I draw a line arrow, so that represents a vector quantity. Now I can take, for example, I can take something like this, right? Now let us say this point is R and this is S. RS is a vector quantity, RS. You don't draw like this, right? On that you only draw a arrow like this. For example, I draw one more, let us say like this. Fine, and this is going in this direction, RS, PQRS, T, U, let us say, UT is a vector quantity. And watch carefully, PQ, vector, RS, vector, UT, vector, can be any vector, fine, but direction is given very specific. So when I want to locate it, I always have to have origin, x-axis and y-axis, and I can refer to that particular displacement, fine, or position. Let us take RS vector. Now what is the origin? We need a reference point, right? I take a reference point like this, right? This is the x-axis and this I mark it as y-axis. Now RS, this is the starting point, this is the end point. So this is called tail of a vector and this is called tip of the vector. Now here it is there. I can choose the reference like this, x direction, this is y direction, and this is a negative x direction, yk. Now this is the origin point, ut again is a vector quantity. Now I hope you understand, a vector is represented by a straight line, in a different angle, in different position we can take. But remember, the magnitude and the length of the line should remain same. So let me continue with the point now. Let us take, for example, if there is a body starting from this point A, fine, and origin, let us say, this is always, let us say, the better towards origin. Now it is going to travel 5 kilometer, fine. So 5 kilometer, I take 50 centimeter, fine. This represents 5 kilometer. P, let us say the point. So this is the vector quantity, right? Now I can take an x-axis, a y-axis, and this is lying in the x-axis, no problem. Suppose if P is not lying in this, okay, if P is not lying in this axis, this is x-axis, this is y-axis, fine. I locate a body. Now think, imagine, for example, we are playing carom board. In carom board, this is the reference line I got, and I got the red coin in this point, let us say. I got the red coin in this point, let us say. This is the point P and this is the point O, origin. So I join with a line like this, right? So this OP vector stands for position, okay? Position of, this is called a position vector. I hope you understand. OP is the position vector. This is the red coin. So when do we need vector? Whenever we talk about two dimension. What are the two dimension? In the one dimension only one axis. In two dimension what's happening? We have x-axis, we have y-axis. So naturally to locate the position you need two values x and y. And also we cannot simply say, for example, it is lying 1, 2, 3, 4. It is 4 units in this and 1, 2, 3, 4. Let us 3 units, let us say. 3 units it is lying from here. Fine. So 3 units. I can locate this body with x value and y value. That is 3 units, 4 units in the x value and 3 units in the y value. So this gives you the position vector. Okay, position vector of an object. So you have to be very clear that a vector quantity is represented by a straight line and the magnitude of this, whatever the length we have taken, should be equal to what is the vector's value. Let us say what is the vector's value and position, the direction. Now how do you get the direction? See, we take this as north, south and east and west. It is somewhere lying between east and north. Okay, so I should know this angle. This angle is theta. Okay, this is somewhere like this. It is in the northeast direction. So later, when we go on doing more and more exercises, you will be able to understand how the vector functions. In the next video, we will see more about it. Thank you so much.